Thank you, Dina. A round of applause for Mr. Mo in the back for keeping everything flowing. Thank you, Mo. All right, good morning, everyone. My name is Sepp Haukebo. I'm with the Environmental Defense Fund. We've heard a lot this week, especially today, about some fishery-dependent and some fishery-independent data collection, but I'm going to be talking about ocean observations, so kind of zooming out a little bit. I want to say Molo, which is Osa, the language of the people here on the coast. Molo means good morning, so use it often this week. Molo. All right. Beautiful. So, real quick, a little bit of context setting. One of the biggest problems we face in ocean observation is massive data gaps across the globe. And I'll start with the example of sea surface temperature. Satellites provide, of course, a lot of sea surface temperature data around the world, but it's only on the surface, and it's highly uncertain in coastal areas. There are some solutions to help fill those gaps, like Argo floats, as well as ocean gliders, but these are incredibly technically intensive and also expensive. One solution that we've been working on through the Fishing Vessel Ocean Observation Network is really using and leveraging fishing vessels, which represent one of the largest latent sources of data collection across the globe. You can see here, this is just commercial fisheries, and this is really just primarily using AIS. But if we fill in recreational fisheries into this data set here, we would have virtually every coast around the world covered, right? And that's one of the biggest areas, the coastal areas, where you see a lot of that, the data issues from the sea surface temperatures, the satellite sea surface temperature data collection. So a little bit about FVON. This is really working with commercial and recreational fishers around the world that are primarily operating in the shelf and coastal seas. Again, you look at just commercial fisheries, there's over 4 million fishing vessels that operate globally. So this represents a huge opportunity for data collection. Fishers can collect data, and that can include sea surface temperature, but temperature, dissolved oxygen, pH, there's a number of different parameters. All as part of just normal conducting their fishery, right? So essentially, what we're working on here, and I'll talk about the Bahamas context, but you can see this sensor here, which is about the size of a water bottle. This is just temperature and depth. But you can attach it to lines, you can attach it to a fishing rod and reel, you can even attach it to a diver or a spearfish, like Valerio was sharing on Monday. And really, they don't have to do anything extra. The sensor goes along for the ride. You basically automate the data collection process. So this can be highly cost effective and very scalable around the world. So we've been doing this for a few years through FVON. One of the earliest places was in New Zealand through the Moana project. Obviously, there's a lot of scrutiny around the quality of the data that has to go into this in the early days for it ultimately to be accepted on a global stage. So today I'm going to be talking a lot about the Bahamas and why did we run this pilot in the Bahamas. This is an image of Hurricane Dorian, one of the most powerful hurricanes to hit the Atlantic Basin. The Southern Hemisphere, of course, you call them tropical cyclones. Quick show of hands, who's lived through or experienced a hurricane or tropical cyclone? All right, good amount, right? So in the U.S., we look at like a Cat 1 hurricane, Cat 2, most people are like, oh, no big deal, right? Let's have a hurricane party, let's drink some rum. You start talking Cat 4, Cat 5, that's catastrophic, right? People need to get out of the way. This is not about hunkering down, this is completely getting out of the way. So one of the issues is that hurricane forecasting has come a really long ways in the last 20 years. The track forecasting especially has improved, but the intensity forecasting has not. So here's an example from Hurricane Dorian, where you've got all of the models showing that it's going to be Cat 3, maybe a Cat 4. And the actuality is that this came in as a Cat 5. And anybody that saw the news knew that this is one of the biggest catastrophes to ever hit the Bahamas. Sat over the northern islands of the Bahamas for several days. Lots of life and destruction of property. So if we're just looking at sea surface temperature, and really it's the latent heat in the ocean that determines the intensity of a hurricane, right? If temperature, it's not enough to understand the whole picture. If there's really warm water down deep, that hurricane is gonna suck up a lot of that energy. And that's really fed off of energy above 26 degrees Celsius, down to like 100 meters deep, which is also where a lot of fishermen collect, where they're catching fish, right? So with climate change, we're gonna see more and more rapid intensification of hurricanes. Why is this a problem? Again, if you're looking at a Cat 1 or Cat 2 and it's 2 or 3 days out, you're probably not gonna be moving. But there are some examples, especially from the last 10 years, where these hurricanes have ramped up from a Cat 1 to a Cat 5 in a matter of 1 day. And it was not predicted, right? So you look at Hurricane Dorian, you look at Hurricane Ian, and you look at Hurricane Otis. These are all examples of rapid intensification. And really, no time to prepare means deadly consequences. So again, we're looking at the Bahamas because this is a heavy hurricane activity area, but it's also a hub for the entire Caribbean and the entire eastern seaboard of the U.S. A lot of the hurricanes that are moving into the Gulf or up the eastern coast are moving through the Bahamian waters. So we worked with commercial fishermen as well as fishing guides and sport fishers to deploy these temperature depth sensors across the Bahamas. We started with 10 vessels, which is a pretty small number, but we've had tremendous results so far, and we've had data coverage spanning from the northernmost to the southernmost parts of the Bahamas. So this is actually where we've been collecting data all across the Bahamas. And for reference, this is the one glider that operates in the Bahamas and collects at depth temperature data collection for NOAA. And this is operated out of the Cape Eleuthera Institute. So if we go back, this is where FVON has been collecting data at depth, and this is where just the glider has been collecting. So you can see a huge difference in spatial and temporal data collection. So the results, like I said, the pilot was a resounding success over the last year and a half. We got over 4,600 temperature profiles, and we're still working on that. About 247 days of those profiles, which is about 81%, was where the sea surface temperature exceeded that rapid intensification threshold. And then about 388 days from that year and a half time frame, which was about 86% of the days, were above intensification at the bottom profiles. And this is actually only with 7 of those 10 vessels reporting. One thing I'll say that I've left out is building trust with anglers, and that's commercial fishermen as well as sport fishers, right? One of the things that's interesting is they can access this data immediately. So sport fishers, especially those that are doing like bottom drops and want to know where that thermocline is, they love seeing this data, right? So it's not just citizen science, there's a two-way street here where they're provided the data immediately as well. And you have to put in a lot of what we call pelican hours, right? You got to sit with the fishermen. It's not going to be 9 to 5. It's going to be a lot of bar time, like Nelly was saying this morning, right? And so building that trust, being able to do these installations, and also letting them know this is not for monitoring, this is not for enforcement, this is strictly for data collection. That goes a really long ways. And there's a lot of people that talk about that in the fishery dependent side is, why don't you actually write tickets based on somebody submitting something from an app? That's the best way to kill your citizen science program, right? Build that trust, let them know it's not for enforcement. So real quick, in closing, where do we go next? Well, we're gonna increase the vessel network size here in the Bahamas, including more recreational fishermen, especially we've got really good data from the deep drop fishermen that are sometimes dropping down to 500 meters, some crazy numbers that we're seeing. But expand those data uses also to early warning systems, right? So think about how we could use this data as fisheries ecologists, as fisheries managers, thinking about shifting stocks, right? Thinking about rapidly warming waters around the world, coral bleaching, marine heat waves. These can serve as early warning systems, but also really help us on the scientific side. So we are currently also expanding this across the globe. One of my colleagues just got back from Tanzania, where they're working with artisanal fishermen to deploy this. Again, the beauty is it's kind of self-automated. Once you set it, you forget it. And then fishermen are collecting the data, as we say in the Bahamas, by Bahamians for Bahamians. You can insert whatever country you're working on. So if anybody is interested in collaborating, please reach out. We'll continue to expand this. And want to say thank you. I've got a QR code for anybody that wants to check out the FVON website. But yeah, thank you. And go ahead.